In this next set of problems, we'll be looking at how inverse trig functions interact with their regular function counterpart. So as we saw last time, the solution to any inverse trig function is an angle. So I plug a unit circle value in and I get an angle out. So in these interactions, if the inverse function is on the outside, so like in example 25, where I'm taking the sine inverse of the sine of pi over 8. So again, that the outside function is the inverse, then the solution is going to be an angle. Compare that to if the inverse function is on the inside, like in example 29, where I'm taking the sine of the sine inverse, then I'm getting some sort of a unit circle value on the outside. And so in an ideal world, these two functions should just undo each other. So sine and sine inverse are meant to just undo one another. So hopefully, and again, if this were an ideal world, we'd be able to just get the same value right back out. But because of the way that we have those restrictions where we're only limited to specific quadrants, that won't always work out to be the case. But at least for a couple of these, they'll work out nicely. So in example 25, where I'm taking the sine inverse of the sine of pi over 8. Since pi over 8 is within the restriction, it is inside negative pi over 2 to positive pi over 2, I get that the solution here is just pi over 8. I don't need to know the value of sine of pi over 8. I just need to know that pi over 8 is in between negative pi over 2 and positive pi over 2. It is within the restriction, it's within the range of sine inverse. So I just get that angle right back out. I can do the same thing with 26, the tangent inverse of the tangent of negative pi over 5. Again, that angle fits within the range of tangent inverse. It's inside that restriction we've set for ourselves. So our solution is just negative pi over 5. Where again, I don't need to know the value of tangent of negative pi over 5. I just need to use tangent and tangent inverse to undo one another. In 27, I'll be looking at the cosine inverse of the cosine of 2. Since there are no degrees listed there, it's implied that that's 2 radians. So I want the cosine inverse of the cosine of 2 radians. So I just need to check to make sure that 2 is within the restriction for cosine. So within that range of 0 to pi for cosine inverse. And since pi is about 3.14, 2 is in between 0 and pi. So our solution here is 2. Now, if we look at doing some of these the reverse way, now I want the cosine of the cosine inverse of 4 over 5. I just need to make sure that the number on the inside is within the domain of a cosine inverse function. Because remember that for cosine inverse, I can only plug in numbers between 1 and negative 1. But 4 over 5 is less than 1, which means that 4/5 is within the domain of cosine inverse, so the cosine of the cosine inverse will be 4/5. Compare that to 29, where I want the sine of the sine inverse of 5/4, where now 5 over 4 is greater than 1, meaning that it is outside the domain of a sine inverse function. So if I try to take the sine inverse of 5 over 4, I'm not going to get a solution. It's the same as asking what angle gives a sine value of 5 over 4. We know that's impossible because sine can only go as high as 1. So no solution for problem 29. However, tangent inverse doesn't have such weaknesses. So the tangent of the tangent inverse of 7 is 7. Okay, then I'm going to get the sine inverse of the sine of 3 pi over 2. So now I've got a value that is outside of the restriction, since 3 pi over 2 does not fit the range for sine inverse. So I'll just need to find an angle that does fit within that restriction, an angle that is in the range of sine inverse. And an angle that is within the range of sine inverse and has the same sine value as 3 pi over 2 is going to be negative pi over 2. So it's just a matter of finding that negative coterminal angle. In the case of an angle that is already in the fourth quadrant, but that needs to be adjusted to that negative value. In 32, I've got the cosine inverse of the cosine of 7 pi over 6. So I want an angle that fits the range of cosine inverse, but also has the same value for cosine as 7 pi over 6. And that's going to happen at 5 pi over 6. A half step that we can take to get there is to say that this is the same as the cosine inverse of negative root 3 over 2, since we know from the unit circle that the cosine of 7 pi over 6 is indeed negative root 3 over 2. And then take the cosine inverse of negative root 3 over 2 and get 5 pi over 6. Next, on 33, I want the sine inverse of the sine of 2 pi over 3, which would be the same as the sine inverse of positive root 3 over 2, since sine is positive at 2 pi over 3, which must happen at pi over 3. So notice in these last three cases, we don't necessarily get that sine inverse always just undoes the sine function, so we don't always get to get the same angle back out, but we will get some similar angle that comes out. So it'll probably still be in that same class of angle. So in 31, I still had a pi over 2 class of angle. 32, I still had a pi over 6 class of angle. 33, I still had a pi over 3 class of angle. I just needed to find one that fit the restriction. I needed to find one that was in the range of my inverse function. And we'll continue applying that idea for the last three problems as well. So I want the tangent inverse of the tangent of 11 pi over 6. So I want an angle that has the same tangent value as 11 pi over 6, but that fits within the restriction. That must be at negative pi over 6. Now for 35 and 36, we're now going to be looking at some angles that aren't that aren't ones that we have memorized from the unit circle. So 35, I want the sine inverse of the sine of negative 2 pi over 9. But negative 2 pi over 9 is within that restriction. It's in the range of sine inverse because it's between negative pi over 2 and pi over 2. Meaning that, again, I don't need to get the actual value of the sine of negative 2 pi over 9 to know that the sine inverse function will simply undo that sine value because it fits within the restriction. I should see the same thing happen in 36. I'm looking at the cosine inverse of the cosine of 4 pi over 5. But again, that should fit the restriction for cosine inverse. Since cosine inverse's range is 0 to pi, and 4 pi over 5 is less than pi, those two functions should just undo one another. And I get 4 pi over 5.